Imagine looking up at the sky and realizing that the star lighting your world is far more violent and mysterious than it appears. From Earth, the sun looks calm, a simple glowing sphere hanging overhead. But beneath that familiar shine lies a constantly changing world of superheated plasma, magnetic storms, and colossal eruptions. What makes the sun even more incredible is that scientists can observe it using different kinds of light. Human eyes only see visible light, but the sun emits energy across the entire electromagnetic spectrum. By observing wavelengths we normally cannot see, researchers have uncovered hidden layers and structures inside our nearest star. And here's something surprising. The sunlight reaching Earth is already about 8 minutes old. Even more fascinating, some photons may spend thousands of years slowly traveling outward from deep inside the sun before finally escaping into space. Let's begin at the sun's outermost atmosphere, the corona. The corona is an enormous halo of plasma extending far into space. Normally, it remains invisible because the sun's bright surface overwhelms it. But during a total solar eclipse, the moon blocks the bright disk and reveals this glowing outer atmosphere. Using extreme ultraviolet observations, scientists discovered something unexpected. The corona reaches temperatures of around 1 million degrees Kelvin, far hotter than the visible surface below. Inside this region, some of the most powerful events in the solar system take place. One of them is the solar flare. Solar flares occur when magnetic fields twist, tangle, and suddenly snap into new positions. In seconds, they release enormous amounts of energy into space. Another strange feature is the coronal hole. These darker regions contain thinner plasma and allow streams of charged particles, called the solar wind, to escape more easily. When these particles reach Earth and interact with our magnetic field, they create beautiful auroras near the poles. The corona also contains giant arcs of glowing plasma called prominences. These towering loops are controlled entirely by magnetic fields and can stretch hundreds of thousands of kilometers into space. Sometimes, plasma cools and falls back toward the sun in glowing streams known as coronal rain. And occasionally, magnetic structures become unstable and erupt. When that happens, billions of tons of solar material can blast outward in a coronal mass ejection. If directed toward Earth, these eruptions can interfere with satellites, communication systems, and even power grids. One of the most fascinating discoveries is that different wavelengths reveal completely different versions of the sun. Some expose calm, looping structures. Others reveal hidden regions filled with extreme heat and violent activity. It's like switching between layers of a living map. Moving inward, we reach the transition region. This layer is incredibly thin, only around 100 kilometers thick, but temperatures suddenly jump from thousands to hundreds of thousands of degrees. Scientists still don't fully understand why. Below it lies the chromosphere. This reddish layer extends roughly 1,700 kilometers above the sun's visible surface. Here, we find one of the sun's most fascinating phenomena: spicules. Spicules are narrow jets of plasma that shoot upward at incredible speed. They appear suddenly, rise high above the surface, then disappear within minutes. For years, researchers struggled to explain how plasma escaped upward through such powerful magnetic fields. Modern models suggest neutral particles may help carry material upward and create these spectacular jets. And finally, we arrive at the layer we actually see, the photosphere. Even though it looks solid, the sun has no real surface. It is made almost entirely of plasma. The photosphere is simply the layer where light finally escapes into space. One of its most recognizable features is the sunspot. Sunspots appear darker because they are slightly cooler than surrounding regions. These areas form where magnetic fields block heat from rising normally. Scientists have also discovered that active sunspot regions are often linked to powerful solar eruptions. If we zoom closer, the sun's surface reveals something even stranger. It appears covered with countless moving cells called granules. Each one is around 1,000 kilometers across. Hot plasma rises through the center, spreads outward, cools, and sinks along the edges before repeating the cycle. This process, called convection, is similar to boiling water. But here, it happens on a scale almost impossible to imagine. Some of these flows become so intense that they generate shock waves.